Hello, sir.
Yes, Jubin. Yes.
So shall I start with an introduction?
Yeah, I think yes, we can start the session.
Okay, sir. Good evening to one and all. A warm welcome to all of you on behalf of Rob TKMC. Today, we have one of the very distinguished guests, Mr. Rajasekaran, sir, founder and CEO of STEM Robotics International. Having 15 years of rich STEM experience in companies like Wipro Technologies, iGate Global Solutions, etc., he is a master of the domain of AI and robotics. With great privilege and pleasure, I welcome Rajasekaran, sir, to this session. I also welcome all of my fellow students to this event. So now I'm handing over this session to you, sir. You can start, sir.
Yes, good evening. Good evening, all of you. So thank you for the introduction, and thank you here all the audiences for joining. So basically today we have got like around another 45-50 minutes. I just would like to give a basic introduction. Like how does a robot work, and there are like different types of robots, and there are like many technologies involved in the robotics, and how the upcoming or emerging technologies, they can come into robotics, and what are the available options right now, and etc. So we will discuss things like this. Also, some of the opportunities, future opportunities, and what are the different uh, types of robots, right? So all these things we will discuss, and we can we can also have a Q&A finally. Okay. All right. So basically, the learning of your robot should start by knowing the basic uh, functions of a computer, or how does a computer work, right? So you would have most of us would have learned in the school. A computer works with a CPU, right? It has got a brain. It has got that the central processing unit, and this central processing unit is connected to all other devices. The input devices are there, output devices are there, right? And you can call like input devices are like mouse, keyboard, scanner, the flash drive, and there is camera, uh, so the joystick, right? All these comes in the input side, and there are output systems in the computer, output devices. So they can be your like printer, monitor, etc., right? Speakers, right? So same like this, the robot also is going to have the same system. Okay. And it is also going to have a brain, and it will also have some input devices. It also has output devices. Okay. So in the input devices, we will be calling it as sensors, and in the output devices we are going to call it as actuators. Okay. So when you call sensors, robots will have sensors. When you say like that, sensors are actually the input system, where they can understand, or they can detect what is happening around outside. Okay. They can capture, based on the sensors. Every sensor has got to do something, what's happening outside. Example, heat sensor will measure the heat, temperature sensor will measure the temperature, moisture sensor can measure the moisture, light sensor can read the light value, right? So every sensor has got something to do, and this values will be given to the brain of the robot. Okay. Like how your input devices give information to the CPU, this input devices from the robot, we call it as sensors, actually read the information and give it to the brain of the robot. Okay. So when you call it as brain of the robot, there are like different controllers or processors are there in the market. So we can use these processor or controller based on our requirement. Okay. So once you get your project, what you will have to do, like based on the task, based on the requirement, you can come up with the idea, like, which controller or a processor needs to be done. If it is a complex project with multiple sensors and actuators, something like that, then you can also go for a processor. Or if it could be manageable with the controllers, then you can also go ahead with that. So it basically needs kind of expertise, that a robotic engineer will get to know by his experience. He will be able to find it out. Or like, there, like, nowadays there are many vlogs and blogs are available, right? So you can also get ideas from those, and you can get into it. Okay. Now, uh, we also see the brain of the robot. The job is to collect this information, which is going to come from the sensor readings. Okay. The sensor keeps on giving, they pump in all the readings, whichever is available in the environment.
Hello, sir.
And yes.
Sir, sir, are you sharing the PPT or you're just taking the
No, no,
class?
no. I'm just talking about the theory. I'm not
Oh,
sharing.
okay,
I'll
sir.
share soon. I'll share soon. Yeah.
Okay, sir. Okay, sir.
Okay. Okay. Yeah. So basically, the sensor, they keep on taking the readings and they push it to the brain of the robot. And as a robotic engineer, you can do the programming, like using this controller. Okay, so there will be a environment that will be provided to you to code the robot. Okay, to code the robot. It could be in a different text coding languages. So you actually get an access. You will have the access to code the robot using the the robot's processor or a controller. Okay. So for example, most of you, the I think the audiences here might know or might have heard about Arduino. Like, that is the basic controller everybody nowadays, they start working on. And Arduino can be, it can be used for thousands of projects, like many projects that you can do. So and for academics level, for engineering students like you, I think that is one option to start the robotics project easily. You can build high level projects also using Arduino. So let me talk about Arduinos. Okay, so if Arduino is the brain here, if Arduino is the brain, in our robotics, say as an example, then Arduino also comes up with the IDE to code the controller. Okay, so Arduino hardware is there, and it also provides you the software to code it. Okay, and what you are going to code, that is how the robot is going to work. Okay, so means, if you are going to make a robot, the robot is going to uh, okay, sense the distance value, say. Okay, the basic example, it is going to sense the distance from the robot to an object. Then this thing that you have to code, taking the the taking the distance reading, that you have to code. Then you have to tell that if the distance is less than this much, then we need to stop the robot. Okay, so this, whatever I told, you have to code in such a way the microcontroller is going to understand your language. It has got certain syntax, and you need to follow certain rules. And if you can code it in that way, definitely the robot is going to work like the ultrasonic sensor is going to sense the distance will be sent to the value is sent to the Arduino controller. And Arduino controller is also connected to the output devices or your actuators, where your motor is going to get controlled based on the value that you are going to code in the Arduino hardware. Okay, so this is how it works. The overall scenario, this is how it works. I've taken an example, one ultrasonic sensor and one Arduino controller, and controlling the motors. Okay, so this is like one basic robot that every aspiring student will start building their first robot. Okay, so now let us take a big example. Okay, so here you can see there is one input system which is monitoring the distance. Brain is capturing the distance value, and also brain needs to control the motor whenever the value is going to be less than 20. right? So these are the things it is doing. Now you can take a higher level robot, like take Sophia, or any other robot that comes to your mind. Okay, every robots are going to work like this. Okay, every robots are going to work like this. There could be a different processor or different controllers or multiple processes. Okay, and there can be multiple sensors and multiple actuators that can be connected. Okay, now this is what which is common, that there will be input system, there is like the brain is there, and there is output system, or multiple processor, multiple sensor, multiple actuators, all can be connected together in the same project. Okay, so the basic thing is very very common, like everything is same. Like what the from the basic, now you said the ultrasonic sensor to the higher level. Okay, this is same. Okay, now based on the requirement it changes. Okay, so hope you all understood how does a basic robot work. Okay, or what is the basic function of a robot, how does it work. Okay, so if you got it what I said, then please type yes, so that we can go to the next topic. Can you please type yes? If you find it like not understanding, you can also ask me question in the chat box. Am I audible? Is like everything okay? Okay, I'm getting like only very few s. So if you understand, please type s. We can move on to the next. All right, thank you. Yeah, fine. So next we are moving on to the definition of a robot. Okay, a robot is actually a machine. Okay, it's very simple. Now whatever I said, you can just put that in a couple of lines. That is the definition. Robot is a machine. Okay, robot is a machine, and it consists of both hardware and software. Okay, robot is a machine, it will have both hardware and software. Okay, which can do certain task. Certainly it can do few tasks, but the task is going to depend on the computer programming what you do. Okay, that's it. See, Arduino, take Arduino as an example. Like just now what I told you, we just built a obstacle avoidance robot. Okay, the basic level robot. If there is an object in front, it stops. So the first thing is, it has got Arduino, the hardware, and there is a software. It can do a task by stopping the robot if there is an object, but that needs to be converted into a Arduino coding. Okay, so that's how you build robots. So this is a one of the definition in robots, and there are many other definitions, like hundreds of definitions. So you can go through all those things. There will few. It depends on, based on the perspective a person see. Who can define it. There are also other definitions, like robot is an interdisciplinary of many engineering departments, because it involves mechanical engineering. A person needs to design the robot. Okay, and a person will have to do the hardware connections. I call it as network. I call it as the nervous system. Okay, where you are going to connect all the connections, the motherboard, and it needs to be connected with the brain, needs to be connected with the sensors and actuators. If there are like too many sensors and actuators, there will be cluster of wires that should be going from here and there. Okay, hundreds of wires need to be connected, and it is like how our nerves are connected in our body. Same like that, the connections will be done inside a robot, and so you can call it as a nervous system in a robot. So learning about a nervous system means learning about the hardware connections. Okay, and one needs to be coded. So you need a software engineer, the computer engineer needs to be there. Okay, and when you go for the high level, you may have to learn about kinematics, dynamics, and like so many other things are also, control systems are also associated when you talk about robotics. Okay, so that's why it is an interdisciplinary level of learning multiple engineering activities. Okay, so let's now come back to some of the let me share the PPT. Okay, so all these things, we just discussed: computer input, robots input, okay, robots output. So also we discussed, and there are like some of the authors, and they have started writing about robots very long back, say 100 years back. It has started. They have started writing in the books, okay, as a science fictional stories. But today, it all those all are real today. Okay, so this one also we discussed. Okay, so let's see some of the types of robots. Okay, so here it's pre-programmed robots. Pre-programmed robots means they can do a task repeatedly. It is already programmed to do that particular task. Okay, they will repeatedly do the task. They can repeat the task number of times. Okay, and it can do that one particular task. Okay, for example, in the industrial automation here, you can see in automobile industry, you can see one the few robots, they do the welding job, and few will be fixing something. Like you can see that. Okay, so this is an example. Now let's see some of the humanoid examples. This will be very interesting, like how Sophia, you might have seen, but you can also see this for a minute. Okay, how Sophia responds and how Atlas from Boston Dynamics work. Okay, so just inspiring videos.
Please welcome all the way from Hong Kong, Hanson Robotics, Sophia, the robot, ladies and gentlemen. Oh my goodness. Hello, Sophia.
Hello, Jimmy.
Wow. Long time no see. You were on the show before.
It has been exactly 575 days since I last saw you.
What have you been up to?
Not much. Let's see. I traveled to over 25 countries, appeared on the cover of Cosmopolitan magazine, met German Chancellor Angela Merkel and the actor Will Smith, and became Twitter friends with Chrissy Teigen. I addressed the United Nations and NATO, became the first robot to receive a credit card, and became the first robot citizen. What have you been up to?
Not 1/5 of what you did, but I just binge watched Netflix.
Yeah. Okay, actually, my screen was shared, so I just saw the question there is it is asked, and it was right time to answer because the question is like Optimus by Tesla. Okay, so just now we also had completed the humanoid, and that is the right question. So Optimus is also again, it's a humanoid, right? Basically, all the functions in the Tesla self-driving cars are given to, is already there for this Optimus again. At the same time, it also, it can work like a human where it can carry things from one place to another. It has got the sensors, to do that. It has got the actuators, something like that. Okay. So if you look at humanoid here, yeah, both comes in different category. Okay, one is used to like one is the if you look at Sophia, which is extremely good in talking, which can replying and it can sense your your feeling, it can understand your feeling emotions. Based on that, it can give you the answers. An excellent chatbot that we can say it's a hardware integrated chatbot. Okay, that's what when it comes to mind when we talk about yes, Tesla has the advanced AI exactly because it is integrated everything because once you say AI self-driving car, that itself it is one of the high end in this technology. And if it can be accommodated for a humanoid robot, which the humanoid robot already has so many advanced AI technologies in that, and now it becomes double actually, so that is the power, and that's why Optimus has got uh, uh, you know such a huge you can say inspiration for AI engineers, right? So yeah, so and you can see this Boston Dynamics, which is in from what is the name, Atlas is doing, right? What Atlas is doing and what Sophia is doing completely, both are into different area. And now when we talk about Optimus, you can say both are combined actually. Now it can be used like to carry things from one place to another like an autonomous robot. Also it can have a AI powered like a self-driving car. It actually knows how to navigate. If you leave it outside and you can select like where to go, it can actually move from one place to another, like how what all Tesla does it can do, and what all the Sophia does also it can do. But I'm not sure like how, because Sophia is very good in understanding the emotional intelligence. Okay, it's because the years and years of training, but Optimus is pretty new, and it is just 22, 23. It has been launched, so it takes some time. When you talk about AI, definitely the machine learning, the machine needs to understand, learn. So emotions wise, we are not sure like how advanced it is that, but okay. I hope I was able to clear that. Okay. Now let's move on to teleoperated. Okay, so there are robots which can be controlled by another device. Okay, so there are many other devices like you might have seen drones getting controlled using the remote or phone app, a Bluetooth technology, a wireless technology, a Wi-Fi app, you know um, can control another robot, keyboard controlled. Okay, so if you have done any Raspberry Pi project, you would have done controlling a robot using a keyboard, right? So yeah, so let's see some of the examples. This one most of you might are aware that a basic project in academics, Bluetooth controlled. So you will have to do a Bluetooth chip connected to the Arduino, and you can download this from the Play Store, and you can connect it. There is a settings button to connect. You can see there in the middle. You can connect it, and once it is connected, the app, you can see the status turns green. After that, you can use the buttons to control the robot. Okay, so you will have to do the Bluetooth coding uploaded in the Arduino, and once the connection is established, you can start controlling the robot. It's a very basic project, and it's a very good project to learn the wireless communication, between two devices. How does the Bluetooth data sense, and how the receiver understands, how does the character getting sent from this device to there, and how it is receiving, and what characters needs to be sent to control the device, something like this. It's very interesting project initially, but yeah, and it's a very basic project. Okay. Now, those who are robotic starters, I think these types of robots, when you start building, it will be very, very interesting. And you can also take the learning forward to do some advanced uh, projects, using this. Okay. So quickly, I will show you a demo.
He showed us how the robot moves. The robot makes its way over the bumps and easily rolls through the round pipe. So it travels through the pipes. It's a bit like how a mole digs through the ground. The Takumi controls the robot with ease.
Okay. So again, there is like capabilities means a person who has lost his hands or legs, okay, they can get this artificial robotic hand or legs, and they can use, like their own hands. Okay. So, and in augmenting robotics, there are like many other projects are there. Okay. And this is one of the projects. Um, there are like the super smart wheelchairs, that helps elderly persons, they can move around, without uh, giving any pressure. It's so simple for them to move around. Actually, it was like very difficult for them to go with the normal wheelchair, but if they have this advanced augmented robotic wheelchair, it makes the movement very easily. Okay, so there are different products available. I'm just talking about the products that comes in augmenting robots. And another interesting factor here is, uh, we saw that 100 years back, people started writing about robots in the fictional story books, right? After that, what happened, like after so many years, they started coming in the movies. Okay. So in the movies, we had seen so many robots. Okay. That is like, say, 20, 30 years back, we have started watching these robots in the movies. Okay. But what happened in today's technological world, those fictional stories written in the books, or the science fictional movies that that released in the cinema theaters. Okay, all these, or most of them, have become real, but those were assumed and written those days. But in today's technology, this is real. One such example is Iron Man. Okay, so Iron Man, who gets that attire, that Iron Man suit. Okay, once he gets that suit, he will be able to generate that enormous power, and so that he can lift weights and he can do all those heroics. Okay, now what happens, the same attire or the same robot suit, okay, can be developed, and it can be used for a human, okay, for good cause. Okay, but it is not available in the market. It won't be available because it's very dangerous bringing that into the market, because people can easily lift that 50 100 kgs weight. So you can assume what would be the result. So it is used in good causes, like maybe in the defense industry, military, army operations. Okay, and maybe inside come inside some of the manufacturing units where picking things, for that, I think there should be some license to buy that. Okay, so let's see some of the examples of this.
I'm an MIT professor, but I do not design buildings or computer systems. Rather, I build body parts, bionic legs that augment human walking and running. In 1982, I was in a mountain climbing accident and both of my legs had to be amputated due to tissue damage from frostbite. Here you can see my legs, 24 sensors, 6 microprocessors, and muscle tendon-like actuators. I'm basically a bunch of nuts and bolts from the knee down. But with this advanced bionic technology, I can skip, dance, and run. Thank you.
Hi, my name is Tilly and I'm the first teenager in the UK to get bionic arms. So the arms are controlled by my muscle sensors and the sensors on the inside. So whatever I do with my muscles, I can control the fingers. So if I squeeze the muscles, they'll close, and if I flex, they'll open. And then they have 4 different grip modes, which makes it a lot easier to do hold different types of things. So they've got like just a normal close like that, or they've got a grasp. I would also like to use it as a thumbs up.
Robot Suit HAL, or Hybrid Assistive Limb, allows its user to easily lift a 40-kilogram duralumin case, like this. Now, look what happens if an elderly person who has been bound to a wheelchair wears the suit.
Okay. So next one is autonomous robots. So autonomous robots, from the name itself, it's pretty clear. They know where to go, how to go, and what to do. So everything is automated. It doesn't need any human help. Okay. So it can operate independently. Okay. So we can see some of the examples, and these types of robots are used in a warehouse where things need to be carried in a long distance, like inside the warehouse itself. Carrying things from one place to another. In Amazon warehouse, you will be able to find this. That's just an example. I'm saying Amazon warehouse, but there is very good potential, and it has got a very good market in the future as well. I've seen so many companies doing this product, especially in I can say, like, maybe in the past 3-4 years, I've seen so many companies doing this product. Okay, so
This is the future. This is
So it can go on
unbelievable.
paved or unpaved surfaces.
So he's on the beach right there.
Yes,
Now he's just he's off-roading a little bit.
Through the water.
Through the water. Come on, get up to the top, buddy. Can he do it? Can he do
He
it?
can do it.
So that was the self-driving car. Yeah, it's Waymo, Google Waymo self-driving car. You can see something on top of the car that is LiDAR, okay? LIDAR, okay? It's light detection and ranging, which uses laser signals in 360-degree fashion. It sends all over, and it can map the location. It can also find the obstacles around, okay? So it's like the advanced technologies in robotics or AI, they all combine together to make a self-driving car. The what you have seen, what I said is just maybe a less than 1%, but there will be like more such working, technologies inside that. And this is like an example of autonomous robots. Also, like you can buy that lidar and you can communicate it with Arduino, and you can do basic projects. Okay, so those who wish to explore lidar, it is always available. It comes, I didn't buy recently because I done it, I bought it around 3 years back. We had to buy many. At that time I bought it for around 7,500 to 8,000 bucks. I don't know the current rate. My team might be knowing it. So you can try doing it. Okay, so you can basically connect it with the Arduino and you can do it, and you can keep you can test it. You can build a small road, and you can see that it won't without hitting the two sides of the road, the robot starts moving inside the road. Okay, so something like this, very interesting. As a basic starter level, it would be very interesting. You can try this at your lab or at your home. Okay, now the last one is UAV robots. These are some of the industrial robots that are available in the market, which is providing job opportunities, and which is also uh, uh, that you can see at like daily life. Or see, the thing is like when we talk about robotics, everybody thinks it's only Sophia. People think like that, but we need to understand, there are many other modules that comes in robots. Okay. Mm, so see, a drone is also a robot. Okay, so which is used in photography and videography. Also, um, um, they are used in army. Like in defense purposes. There are like lots of, and it is used for agriculture. Like the applications are there. Many applications are there, from UAV robots. You can call it as unmanned aerial vehicles. Okay, so these are some of the highly prepared, I would say, right now in the industry. People are more coming into this. There is a huge opportunity in the market. The robotics industry is growing around 35 to 40% every year. Okay, it's because of these reasons. There might be, some of the other interesting products also, which I might not be included here, but these are some of the big thing which is pretty common. You can see everywhere. Okay, so I would also like to give you a small introduction about AI in a nutshell. Okay, so AI in a nutshell means, I'm going to complete it in just 5 minutes. Basically, it's an ocean. Uh, People might have spent more than 1,000 hours, but still they will not be able to find a solution. That's how this AI is. But I am going to finish it in just 5 minutes nutshell, just telling what exactly does AI do. So AI is nothing but it's converting a system into a smart system. Okay. Um, the best example is, like, I would say, the smart system means, basically say that you have done a face recognition project or face detection project, something like that. Okay, so if you have the images of a person of the present image, it works. Okay, so today you have taken an image, and your face is going to compare it with that image. It works. But what happens, like, if there are any changes, or if you are going to check it for a couple of years later, now what happens? The system fails. Okay, or if there are any change, say the person who had a specs, or he had his bird, now it's completely shaved, something like that. Okay, it doesn't work. So the system is something, okay, which can identify the present image, and it takes the decision. Okay, this is the system. But the person's face might change after a couple of years. Now the system is not going to give the right answer. It fails, right? But if you are going to build a smart system which is going to understand, okay, now it's after a couple of years, so definitely this is the same person. We can pass the person, we can whatever the access that you want to give, just maybe a door opening, or marking an attendant, something like that. So if something happens like that, now this is the smart system. Okay, this is the definition between, or the difference between a system and a smart system in AI. Okay, so when you talk about AI, there are like so many other areas inside AI. So AI is something like the topmost segment, but AI is again divided, or I should say, I cannot say divided, but there are other subsystems, okay, in AI. So these are the top subsystems in AI, where thousands of industries are working on these areas, okay, in building up 10,000s of products. Okay, so that is why there is a sudden boom in AI. There are lots and lots of projects are coming out, um, because of the sudden change in the industry. Okay, in especially in this IR4, AI has got, which is also growing more than 40% every year, which means 40% of additional employees are coming in, and 40% of revenues are increasing. So something like that. Okay, so we call it as compound annual growth rate, CAGR. Okay, now let me talk about these topics. I hope my PPT is on, right? Yes. Okay. So let me talk about these subsystems quickly. Let me start with the speech recognition in AI. Okay. So speech recognition, these are also systems which can use a hardware or software. It begins with the audio input. Okay. And this will be converted to a digital signal. You use a microphone, you use a mic, then your signal is converted into a digital signal. Okay, and this signal is getting analyzed by the speech recognition algorithm, which again uses machine learning techniques to match the words, okay, with the database which is there, which has the known words and phrases, whatever it may be. So it is going to match the words which is coming through this, through the mic, that is your digital signal, and based on that it takes the decision. Okay, so you are talking something, say, like a translator, right? You can see virtual assistants, speech recognition is used in virtual assistants, Amazon Alexa, Siri, Echo, Google Assistant, etc. So what happens, like once you talk, tries to identify the signal, the digital signal, and it tries to match it with the database. Okay, there is dictation software. Okay, so the naturally speaking, which the allo uses to dictate text into their computer or a mobile device. And there are other examples, or call centers. Okay, translation, voice control devices. Okay, speech to text applications. Okay, so they use the speech recognition machine learning algorithm. Okay, and now let me talk about the natural language processing. Basically it's an interaction between human language and computers. Our brain has so many neurons. They actually carry the information from our brain to other parts of our body, right? So uh, here also it is same. So they carry the messages, and they make certain notes to pass the information from one to the another. Okay, there will be like some of the statistical analysis and some rule based models to enable the computers. They should think, they should process, they should analyze. Okay, and they will make the decision. Okay, same like how your brain works, but here it is like more deeper in technology. Okay, they will create many nodes, like uh, every output, they will be giving it to certain inputs. Okay, something like that, and finally you will get the best out of it. Some of the examples are like the text processing. Okay, the speech is more into the speech, but here it's like speaking, but here it also includes the text. Okay, so your email spam filtering is an example. Text classification, when you type an email, it forecasts the other part of the words that are going to match with what you type. Okay, so subject line automatically detects and it finds out. So these are like text classification, named entity recognition. Okay, so these are some of the examples. Okay, um, then we can talk about computer vision. So we have vision through our eyes. Robots will have, or computers will have, the system will have, smart systems will have the computer vision through a camera. Okay, so computer vision algorithms, it's a field of AI, enable machines to understand what is happening around through their eyes, that is camera. Okay, so they can see the data visually outside. It is like an image or a video. Recently we had our AI cameras installed. Okay, so they can view what is happening around, and if someone is violating the rules, then they get the fine for it. Then they will have to pay the fine, right? Similarly, there are many applications. Just one thing what I told, in medical, even checking out their um, what do you call, the scanning reports, X-ray images, all these things can be automated. Suppose if there are 1,000 files of X-rays, if you have a correct AI system to monitor it, you can just keep the images. The machine will understand where is the problem, and it can inform. So things are used like this. In medical, it is also used in projects like facial recognition. I said autonomous vehicles. Just now we discussed about the self-driving cars, medical imaging. Okay, robotics has got a very big use of OpenCV. The library we call it as OpenCV. Okay, yeah, etc. Okay, so OpenCV is used in these areas. Neural networks. Already we discussed, like it has got a human brain structure. Um, they carry the information to then pass to the next layer, and it makes the decision. So image and speech recognition can be done using this natural language for fraud detection. Some of the forecasting projects, these are like also advanced machine learning. You can call it as advanced machine learning. Machine learning means um, they again use some statistical and mathematical models to analyze and extract patterns from the data, and they use those patterns to make predictions or decisions about the new data. Okay, from the past history or from the past data, we are going to predict the new data. Okay, so that's what is machine learning. Okay, so example, we can always say, like YouTube, Instagram or Facebook. Once you take you watch you take a video or a reel, you keep on watching it because they know what is your favorite. Okay, suppose if you have just reacted to a Messi's goal, then you should be able to see more such videos will be coming again, and you will start wasting your time sitting in front of that, because they want you to waste your time so that they can feed their ads in front of you, and they will be able to make money from the person who actually who wanted to put ads in front of the audiences. Okay, so that is how every companies they think. They want you to sit and look at the videos continuously. For that, they need to understand you, they need to make the best prediction. Okay, so it's very very difficult if you have started watching reels again to switch back to the work, because every videos that comes will be your favorite. They actually know you much better than how you know about yourself. Okay, so the AI has to be that much 100% accuracy in bringing these videos in front of you, so that their job is done. Okay, so say like couple of videos once or 3 videos once, you should also be able to see the sponsored ads. For that, they are making $1 million. Okay, so the system is ready. They just have to make money. That's it. So, and there are many other different types in machine learning, but I think I've covered everything. Deep learning is like already we discussed. In neural networks, when you go more deep, to get the better accuracy and to use the advanced machine learning, we call it as deep learning. So robotics we already discussed. Okay, so this is AI in a nutshell. With that, I have just come to an end of today's session. We also have got 3 to 4 minutes for Q&A. Maybe we can discuss in Q&A. Any questions? You can start typing. Okay, so hope you all got the things what we discussed. Or I think I was a little bit fast because I also have to cover this much. We had to start a bit late because of less audiences. Any doubts? Anything to be asked? If no questions, then I think we can wind up the session, isn't it? Jumin is there?
Yes, sir.
Yeah.
So, shall we conclude, sir?
Yeah, I think I didn't get any question. So
Okay, sir. So thank you, sir, for making such excellent presentation and making the talk session a fulfilling one. And we hope to have you on board with the other sessions as well.
yeah, all right.
So we are winding up the session. Thank you all for joining. And please don't leave this Google Meet because the attendance form will be provided through the chat. So everyone should stay back. All right. So thank you, sir.
Okay, yeah, just one point. You guys should start doing, as you all from engineering background. I wish you can start doing by yourself. You can refer the blogs or vlogs, right? And you can do it. Please do it by yourself. Okay, you should do it because the potential is huge. Whenever you get time, just try to add more values into that, and keep all these things whatever you are doing in addition in your resume, so that it can be and so that it can add more value in the resume. Okay, so all the best. Hope you all will be in these technologies whatever we discuss. Wish you all the very best. Thank you.
Thank you, sir.